ladies and gentlemen. It is my pleasure to welcome you to the 3D sensing session of the Pepperl+Fuchs Digital Summit in 2020. A new format, a digital format of a fair, of a summit, of a come together with our customers. Because of the COVID-19 pandemic, we are not able to actually welcome you on our fair booth in Hanover or elsewhere, and therefore we invented this new summit, digital summit format to really stay in contact with our most important customers. What does it mean, power of 3D? Why is it important to think about 3D sensing? Well, first of all, we need to understand that digital technology is rapidly growing inside the applications of industry and specifically inside of the shop floor. And this is very much pushed by international technology coming from the super large hyperscalers of the Americas like Google, Apple, Microsoft, Facebook, and most important, Amazon. They invest much more money into research and development compared to VW, still the largest car manufacturer of the world. And they can focus on just digital technologies such as artificial intelligence, cloud computing, and big data analytics. Now, with this enormous boost of technology, we are able to really change the world. And these ideas are extremely powerful. You can see that Tesla's market capitalization, because of their vision of a full battery-powered electrical car, is larger than the stock value of all the three large car manufacturers of Germany altogether. And this despite the fact that the efficiency in building cars is still significantly lower in Tesla compared to the three German brands, and even more when you compare it to the largest car manufacturer in Asia Pacific, Toyota, which builds 28 cars per employee a year. This technology, this digitalization is not only happening in the car industry, not only happening in social media and in the industry. It happens in all our life sectors. When you imagine, for example, smart health, it is expected that the average life expectation should actually grow to more than 100 years if we really apply all the available digital technology in monitoring our health status, in getting smart AI-based diagnostics and all the things which are possible, which are feasible with technology as of today. And no wonder this technology also moves rapidly into the industrial applications. But very often we have a technology, we have something to innovate, but we lack the idea what to do with it. And it's important to understand that an innovation never starts with technology, but it starts with an idea. So the idea, the invention, turns money into an idea, whereas the innovation turns the idea into money again. And of course, enterprises try to make more money with innovation than they spend into invention. But the invention is the first necessity. So what to do? What's the benefit that we create for the user with the technology? This is to be the important point to be understood before we actually start implementing the technology. And we can go through the different layers of industry to understand what could be the benefit when applying the new digital technologies. Let's start with the shop floor first. As you can see, the shop floor today includes factories, plants, machines, systems, devices, and stands for efficiency, quality, throughput time, but also utilization grade, availability, safety, environmental protection, and last but not least, also explosion protection. And it's all under the clear requirement of real-time availability of data. In this shop floor, we can use these new technologies to further raise the efficiency, to improve quality, to gain flexibility. People are dreaming from products really down to single quantities, really to fulfill every individual customer wants and needs at a price of mass production. And this is really applicable for some of the industries. And of course, we also tend to create even more safety in our plants. But essentially, this is what we always did, but now with new technology. On the office floor, it's a bit different. We can use the new technologies, as you can see, for gaining transparency by creating availability of data and understanding of data, but also transmitting the context information of these data. So it's not important to know what temperature that individual temperature sensor is giving us only. It's important to understand what's the expected temperature that these sensors should give us, what are the boundaries in which the process is still stable, and what could be dangerous and what could be abnormal in this understanding. And this is meant by context information. And of course, it's very important to understand volume is the key. Big data is helpful to really understand the complexity of our processes. But the real new benefits are on top of all this, on top of the shop floor, on top of the office floor, in the new software applications, what we call the data-driven business models. And they are supported by cloud computing and artificial intelligence in a much larger degree than what we would find on the office floor and the shop floor as such. And this is really the new benefit we are all looking for. And this new benefit has highly disruptive potentials in difference to the optimizations on the shop floor or the transparency on the office floor, where we actually improve things in a more evolutionary way. The revolution really takes place on the very top level of the data-driven business models. These business models could be augmented reality, just as an example, to give maintenance people, plant engineers, the full set of information, even combined or overlaid. So digital information from our CAD drawing systems, measurement informations from our control architecture, and simple pictures that could be taken, for example, by a mobile device like an iPad or a smartphone. And combining all this gives us augmented reality, gives us a much deeper understanding of what we see and what we need to do. You even can bring in procedures to tell people what to do in a maintenance case, in a repair case, or whatever, with these augmented reality technologies over there. This is a complete new tool set that allows us to completely change also our approach into maintenance and repair, and that has highly disruptive character as it changes the way we worked for many, many years. In the same way, you can look into intralogistics, into warehouses. Warehouses like they are used today do not require a complete information about all the 3D environment because it's highly deterministic what we do. We construct these, we build it up into plans. It's highly static. Only the base carriers are moving. The rest of the shells are absolutely static and highly accurate. But what if logistics changes into a picture like this, where you see no shelves statically mounted to the ground, but on top of smaller cobots that actually transport the entire shelf either to people doing the commissioning or again to other robot stations doing the commissioning into parcels and send them to the different dispatching units over there. This kind of cobots would definitely require much more detailed information about their 3D environment, and they use sensors like sensors for tracing and tracking on the ground, but they also need scanners, LiDAR technology, 2D, 3D to really get a complete 3D image of their environment if they have to move and maneuver autonomously. We use this kind of 3D or 2D technology already for quite a time. When you look at VMT, our image processing company over there, they use this laser technology for gap-free body assembly in many of the car manufacturing plants around the world. More than 250 implementations have been established throughout the last 5 years of what we call best fit, which is our trade name for this kind of assembly expertise. We use 3D technology in determining cracks, micro cracks in very sensitive turbine chassis in our joint venture 3D Aero, a joint venture with Lufthansa Technik. Lufthansa provides us the applications and also the business, and we provide technology into this joint venture enterprise. And in this case, we all started with a complete inspection of a part of a turbine, the chassis, which is very valuable and sometimes is endangered by micro cracks that we can find with this kind of 3D interferometer, micrometer accurate information. But we also use this when we dispense glue, for example, to a windshield for a car, and which is not mounted anymore, but simply glued inside the car body. And therefore, it's very important to understand that we have a highly accurate dispensed glue to really assure the necessary quality and make sure that we can document the quality in the right way. This is a 3D sensor that really is capable to even add another axis, another degree of freedom to the robot as the sensor itself turns about the inner axis over there. A typical 3D measurement application. And last but not least, we can think about having a 3D information about an entire robot cell or even an entire plant. If you want to copy one robot cell to the other, then it could be very, very beneficial to have a complete 3D information. If the robot should do anything autonomously inside that cell, it is important to have a 3D information. And the nice thing about 3D, it's not just a nice colorful picture, it is actually giving us the chance to look at every of these pixels as a vector in an XYZ coordinate. And for better visibility, we actually added a color information to this XYZ vector, and this is called Pepperl+. You will learn more about this in the presentation following my short keynote. So 3D information is essential for the next generation of autonomous and automatic systems, be it cobots, robots, collaboration robots, whatever you intend to do in modern intralogistics and manufacturing requires a much better 3D information. And Pepperl+Fuchs is here to help you in your task for 3D sensing. Thanks for listening.